Hi, I'm Marcel-Jan, writer of the blog mbasOracleblog.wordpress.com, and I've also created a script called sqlperf.sql, and you can find it on my GitHub repository. And well, as it goes with DBA scripts, DBAs don't have a lot of spare time, so you might have found this script but haven't run it yet. So I want to explain something about this script and why it could be useful for you. It certainly is useful for me because at first I wrote it for myself to help me with a lot of performance issues. So you're running the script in SQL+. You need a SQL ID to find the SQL statement in memory and AWR data. The script does that for you, of course. It also asks you the child number, and you might think, I don't know what child number to choose, but usually there's only one per instance. Here I had a real application cluster, so there were two instances where the SQL statement had run, and apparently there were different child numbers, and apparently there were a lot of child before, and now we're arrived at number 35 on this instance. So you need to choose when you're running this and you see this output. Of course, you don't see it in HTML, but the script gives you a list in text, and you can find a child. Usually they're not all that different, but you might want to check. For example, for different childs could be different execution plans because there are different binds. There's different data in the bind variables, for example. Not that you get a child for every different value in bind variable, but that's what could happen. So here we have this SQL ID and the child number, and you can see when it was last loaded and when it was last active, and you can see the number of users opening this. And then in this HTML output you get a lot of other information. So first of all, at the top you get this index. You can click on these links. It's rather handy, so if you want to know the execution plan, you just can click here and you get to the execution plan. But we'll get to that later. First of all, you probably want to know, hey, what is the query that I'm trying to tune? So you can click on that, and there we are. We have the full text of a SQL statement. This is from memory, from $3 to be exact, but you can also, when it's flushed out of memory, you can also get it from AWR, not from memory, by the way, but AWR. Thing is, when you're getting information from AWR, you should have the diagnostic spec license. Otherwise, you shouldn't run the script. I want to make a script that doesn't use AWR data in future, but it will have a lot less information, unfortunately. I actually can wholeheartedly recommend the diagnostic spec, the Oracle diagnostic spec. Okay, so we get the full text of the query, and next we find a lot of different all kinds of information about the query that has run. For example, you can find SQL baseline data. When you have the optimizer capture SQL baseline parameter is true, you might find out that you have all kinds of baselines in memory, and these are guarding your execution plan. These are a SQL plan stability feature, but sometimes you don't want that stability, so you might want to review this information if you're having issues with SQL baselines. This is the accepted SQL baseline, by the way. This one isn't accepted, but if there are no accepted, you might choose one, probably based on the optimizer cost, so I put it in there as well. And here you can see when the SQL baseline was created. You might find out in some cases these SQL baselines might herald from years ago. Well, they could be quite old. There could also be SQL profiles when using the SQL automatic SQL advisor. That's another license. This is the SQL tuning pack you want to have for that. But in this case, there wasn't a SQL profile. But apparently, you still get SQL profile metadata for some reason. So I'll put it in there. So here you get some general information, the number of executions, the response time. This is a response time for all executions in this info. So you can see for the 95,000 executions, it ran 278 seconds. So that's quite good, unless you're running a really fast website and it actually isn't good. Probably the business knows better. The application administrators hopefully know better than you, because you're a DBA. You're not supposed to know. You're not always supposed to know how fast is fast enough. You can also see already that apparently 41.5 seconds were used for CPU time, and the others for here 200 seconds for I/O wait time. Now, actually, if you want to know where the response time was going to, you might want to check different tools than this one. This is very crude, but it's the best I could do. You can see something about the memory, and you can see something about who ran the query. Now this is interesting. So here we have a username, and we have a service name that apparently was used, and here we have a module name and action. Now this could potentially have a lot of interesting information if somebody bothered to use DBMS application info, that package, to put it there. But now we just see that some Java some Java application run this via JDBC, and yeah, it could be anything. But this could say this is the order application, and we were actually creating an order as action, and then you have this very powerful, but unfortunately not used here. So on we go. Then we have adaptive cursor sharing. Adaptive cursor sharing is a way to say, for example, when you have a query that is select on a status column, and of that status column 1% is status to do and 99% is status finished. Now you might want to have a different execution plan for the status finished than the status to do, because hopefully for your company's sake the status to do occurs much less and the finished much more. But yeah, and in that case SQL adaptive cursor sharing could be really handy. It's a Oracle 11G feature. Now there could be bind mismatches. That's sometimes an issue. In this case I'm only seeing purge cursor, and that just could say, hey, I had to create a new child because the other ones were purged from memory. Sometimes I finding bind mismatches here that don't give me a lot of information actually. No. But yeah, sometimes you can find. I found an issue with different data types for different bind variables that were basic for the same bind variables. That could be interesting. Then we're looking at the bind variables here, and these are the bind variables for this cursor, this child number we chose. You can see an example of bind variable, and yeah, maybe you want to check this out and run the query and find out what's actually happening. You could also use this to set up a run of the query, or just the execution, getting the execution plan in real time, and you could then do event 10,053 trace to see what the optimizer was actually up to. And here you get the bind variables for all the other childs. So that's a lot. And I'm going to skip ahead. So we had bind mismatches, content of bind variables, and the other childs. And now I can just go to dropping sql baselines, because sometimes I want to, because, well, you know, sometimes sql baselines are old and old hat. And then you might want to get rid of them. And these are two ways of getting rid of them. This is one that gives an error but does the job. And I recently found out on the Oracle support site that this is actually the way to do it. And this doesn't give an error. It's actually running quite nicely. So I think I'm going for this one in the next versions. Only this one and not that one. But even when you got rid of your sql baseline, you might want to purge the execution plan because it's still there. So you need a statement to purge that. And you might think you have to purge the entire shared pool, but you don't have to anymore. You can run this to just purge this SQL statement. Now, isn't that nice, or isn't it? I think it's rather nice. Even better, I'm really proud of this part of the output because I managed to get the names of objects that were accessed by the execution plan, and then get all kinds of data for these objects. Basically, what I did was I retrieved the execution plan from DMS plan, and then I went through the data and picked out the object names, and then I got all kinds of information for the object names. And this is really interesting. So here you get the actual statistics for these tables. So you can see, hey, there are a lot of rows apparently in the ABC users table. So hey, okay, that's all something that's already nice to know. But even better is, and I wrote about this in the blog, is I can get statistics history for tables. Now this again comes from AWR data. So I'm pretty sure you need a diagnostic spec for that. Actually, I couldn't find it because these tables I'm querying this on are so obscure. But there are some WRI dollar tables or WRH dollar tables in the sys schema, but very useful. But because look at this, we have this table, and suppose somebody said my query is running about 8 times as slow as it did, and then you can say, yeah, but wait a minute, didn't you have better performance on September the 7th? Yeah, you have this many rows then, and later on today you have, well, about 8 times as much as many rows. So yeah, this could be the issue why your query is running 8 times as slow. And here you can also see the number of blocks. The average row length is also very interesting. It's the same here, so that's good, but this could change while the number of rows aren't changing. So it could happen that the application builders decided that in the next version they wanted to fill up a varchar to 4000 column completely from start to finish. And yeah, that does change something in the row length, and so when you're querying these columns, that also changes the number of blocks that the table is filling. So very interesting. Also here the sample size. Sometimes it can happen that the sample size is very, very small compared to the number of rows, and it can give Oracle, it can lead to wrong conclusions in the optimizer. So this is very interesting, and yeah, I like this a lot actually. I've solved a lot of discussions with this one. And of course for indexes the same. Here are the actual statistics, and here are the statistics history for indexes. So you can see also the row count, and you can see, for example, the distinct keys. If this is changing wildly, well, this is something, yeah, this is something I want to discuss. Also, the clustering factor, it shouldn't change wildly, but if your table is emptied and filled again, this could change because this basically says how your table is sorted compared to your index, and this could change stuff. So there's a lot of information there as well. You might want to check that out. But still, you need the diagnostic spec. So, and actually, I don't know if I said it already, but every time you use these views and tables I'm using in this script, it is ticked somewhere as it's marked somewhere as usage of the diagnostic spec. So if Oracle License Management asks you if they can look in your table in your database what features you've used, they can find that out. So just there's also the actual statistics for indexed columns. Excuse me, but not the history. Well, I can get it, but the query was taking so much time, and I want this query to run really fast. I want to have this running and bam, have it look at it as fast as I can. So yeah, so that is so I have a different script that does have the query on the index column statistics history, and that's SQL stats.sql, and you can also find it in my GitHub repository, so you can find it there. Now here we get some more interesting information. This is a very useful table to me, and yeah, to be honest, I created this script for myself at first, and you can use it and reap the benefits. This is the query history of query response time. And there's much more than just the query response time in there. So you have the response time per AWR begin interval time. So every snapshot that is taken, you can have information about the elapsed time per instance, and you can see the plan hash value that has been used. You can see whether there was a SQL profile, and you can see the number of executions, and you can see the elapsed time per execution. I find that I find it rather interesting to see the elapsed time per execution. So I'll put it in there. Now, in version 1.6 of my script, I also put in these two columns, this one and this one. And this tells me about when I'm running parallel query, how many processes have been used to run the query parallel. This is very interesting in my project I'm working on at this moment for my employer, because in a data warehouse, when you try to run queries parallel, you might find out that with a certain value of parallel max servers, that sometimes other queries trying to use these parallel these processes to run the query parallel, and you might find out that you're running out of parallel processes to use, and this query might otherwise run fine, and then suddenly there are no parallel processes to use, and it runs like well, there's a Dutch expression for that, a wet newspaper. Yeah, you can use that. So this is very interesting, and you can see here for all these snapshots the response time, and further on you will see I've done something interesting with that. Okay, I also when I was reviewing this data, I actually find out there is something interesting about this. This is how what I would have reviewed when if there would be a problem with this SQL statement, and there actually isn't as far as I know at this moment, but you never know. But what you can see here is, hey, at 3 o'clock this afternoon there was this plan hash value, but 1 hour later there was suddenly this plan hash value, and all the time before that it was using this plan hash value. What gives? What was happening? So I want to find that out. You can also see that before the average the elapsed time per execute was much higher here, and suddenly here we're fast again. So yeah, I also want to know, hey, what's happening there? So there's some more information about that I can try to find out this issue. Here are some extra details. You can see these 3 columns are basically the same as in the previous table, but here you can see, for example, the optimizer cost, the number of loaded versions, the version counts. These are basically the number of childs that were running at the time. And yeah, unfortunately, there isn't any useful information in these 2 columns right now. At this output, but yeah, there could be. It could be so beautiful. Okay, running along, and yeah, for example, this is interesting. This last hour, suddenly there were 37 different versions running. Oh, that's odd. But also the optimizer cost was much lower here than it was here. So yeah, what was happening? I want to find that out. What could help me is all the bind information per snapshot from AWR. That's something I put in version 1.6 of my script. This is isn't in the version you're using. This was a mistake I made when I was trying to reduce the amount of data in this table by hand in a text editor, but it isn't there, I promise. But what you can see here is, hey, at this snapshot on this instance, it was running this plan hash value. That's again the same, but I can see a number of invalidations. I can see the bind variable data, and actually only this one is interesting. So I can see, hey, for example, maybe the application used a different data type for some reason first and changed that, or there are wildly different values in the bind variables. It could be rather interesting. So that's in there, and it's giving you a lot of rather large tables with lots of data, but it can be very useful sometimes. So back to the top, and then there is the resistance. It's the performance graph. Yeah, I'm rather proud of this one as well. This is made with Google Graph API or Chart API, one or the other. So you need an internet connection when you're opening this output file in your browser, and then you can see this, and you can see, for example, hey, why was the response time so much higher here than, for example, here? And you can review that in the tables I've shown you before. And then to sum it all up, we have some summation. You can see here per instance, you can see the plan hash value and the average, the maximum, minimum and average response time, and also the standard deviation. Yeah, very sophisticated. You can see the cost. Apparently this has run with this cost, but also with this cost. But okay, so that's interesting. Again, there could be data here, but somebody actually had to fill in the DMS application info data. Really, if you run into your developers, try to sell them using this package. It's really useful to know what the application was doing for you, but for the entire organization when there are performance issues, and for the developers as well. It helps everybody. Yeah, so then there's the response time broken up. So you can see here, this was the elapsed time, this was the amount of CPU. Apparently there was a lot of cluster weight. And then SQL profiles, SQL plain, shareable memory, for what it's worth, buffer gets, disk reads, and the rest. For example, the number of rows processed. So yeah, this is it. I'm using this on a daily basis, this script. And thing is, I've told my colleague DBAs in our team about this script, and basically the response you're getting from other DBAs is, yeah, everybody has their scripts. It's probably very nice, but no, do not have the time until they run it actually, or when I show the output, and then they say, hey, where did you get that data? And then they run it, and I can actually, and honestly say, we have a team of very, we have a team of crack DBAs, but there's sometimes some of them are a bit stubborn, but when they run the script, they're not stubborn anymore. So do with it what you want, or at least if it's good for the world and good for performance. So yeah, enjoy.